All right, so again, good morning. Our aim for today is how do we convert between rectangular and polar equations. Do now is convert r sine theta equals 3r cosine theta plus 2 to rectangular form and identify the graph. Anyone get an answer to this? Feel free to type in the chat or speak up. So what is r sine theta and what is r cosine theta? What is that equal to according to what we talked about the past couple of days? That seemed familiar to me.
So do you just substitute in x and y for r sine theta and r cosine theta?
Oh yeah, that's all it is. Yeah, so r sine theta is going to be y, right? And then r cosine theta is x. So we'll have y equals 3x plus 2. And as you'll see, right, that's a line, right? Slope 3, y-intercept 2. All right, so let me scroll up to the solution. Okay. Yeah, so as Leo said, right, y equals r sine theta, x equals r cosine theta. We're going to substitute to get y equals 3x plus 2, which is a line. Okay. All right, I'll give you a sec to copy that, and then we'll move on to the other questions. All right, anyone still need this? Okay. Yeah. Okay. Are you done copying?
Yeah, thank you.
Okay. Anyone else still need it? All right, gonna move on then. So the rest of the lesson is actually, well, there's no actually like no formal new material. It's just a review of what we saw in the last lesson. So remember to convert from polar to rectangular coordinates. We use the following: y equals r sine theta, x equals r cosine theta. And to convert from rectangular to polar, we use the Pythagorean theorem. R squared equals x squared plus y squared, and then tan theta is y over x. Okay, but these are the formulas that we're going to use to convert between rectangular and polar equations and vice versa. Now, yeah, this is the same thing as last time, but if you want to copy it down, feel free to do so right now. All right, does anyone still need this? Okay, I'm gonna move on then. So after this is just a series of 4 examples. I'll show you what it is, and then we'll go through the solutions. So we're going to convert the following equations the opposite format. So like if it's rectangular, then we go to polar. If it's polar, then we go to rectangular. And then identify the graph when possible. Okay, so these 4 equations we'll work on together. All right, I'm going to scroll up. Okay, so the first equation was x squared plus y squared is 9. All right, and we're going to use the Pythagorean theorem equation, r squared is equal to x squared plus y squared in the context of the polar plane, right? So we're gonna get r squared equals 9, right? So just substitute r squared on the left, you get r squared is 9. And then if you take the square root of both sides, you get r equals plus or minus 3. Now, at this point, you might not realize what it is, but if you just think about it for a sec, this means we have two sets of points, right? We have plus r equals plus 3 and r equals minus 3. And to make that even more patent, I will write these as two equations. Okay. So r equals 3, r equals negative 3. So one with all points of radius 3. So all the points of radius 3 is going to be a circle, right? So if you imagine that, right, it's just, I know there's a Cartesian plane, but yeah, just imagine like graphing polar points on this. So like radius 3, radius 3, radius 3, just of varying angles, right? You get a circle. Something like that, right? All right, and then if you had r equals negative 3, right, instead of starting on the right, you start on the left, right? So you know, graphing counterclockwise still, right? With r equals negative 3, you still get a circle, okay? So in other words, yeah, this is just a circle of radius 3, right? Yeah, and they overlap. They're the exact same graph in the end. Okay, so the answer is r equals plus or minus 3. That's the polar form of this equation of the circle. And this is a circle with radius 3. And actually, I guess you can tell, from the original equation, like x squared plus y squared is r squared, right? You know that from geometry and maybe algebra 2, right? Yeah, you can tell that's a circle of radius 3 from the rectangular form. Okay. All right. But yeah, with that said, we'll move on to part B. Part B is tan theta is 1. And, since tan theta is y over x, we get y over x equals 1. So just substitute that on the left. You get y over x is 1. And then cross multiply, get y equals x. Okay, so there's just a line, y equals x. From there, part C, we have, oh, sorry, did anyone still need the first one? X squared plus y squared is 9. I'm going to talk about this then. I guess I'll leave that up there too. So r equals 4 sine theta. We have r squared equals 4r sine theta. We know that r squared, right? So this is in polar form, right? Because we have r and theta. We have to convert to rectangular x, y. So at this point, you might be tempted to divide by sine theta, to get r over sine theta. But, that's like that. We end up getting like r cosecant theta, which is not something that we know as of yet, right? So what I'm going to do here is actually I'm going to multiply both sides by r. Here, multiply both sides by r, you get r squared equals 4r sine theta. So r squared is equal to x squared plus y squared, as we know. And then r sine theta is y, right? So this becomes 4y. So we get x squared plus y squared. And then I'm going to subtract 4y from both sides. You get x squared plus y squared minus 4y plus 4. Okay, so here, note here I completed the square, right? So here in the last step, I added was negative 4 divided by 2 squared, right? So remember, completing the square is a way we can write the equation of a circle, right? So we're just adding 4 to both sides, and I know it's 4 because you take the linear coefficient, which is negative 4 in this case, you divide by 2, and then you square it. Hopefully you remember that from algebra 2. But yeah, negative 4 divided by 2 squared is equal to 4. You add that to both sides. The reason for that is we get a perfect square trinomial, which we can factor, right? So this is equal to y minus 2 squared. And this allows us to write our circle in the form x minus h squared plus y minus k squared is r squared, okay? It's at both sides. So yeah, that's your final equation right here. X squared plus y minus 2 squared equals 4. And there's a circle with radius 2, center at 0, 2. Okay, we know it's a center at 0, 2 because, you know, x minus 0 squared technically. And then, yeah, the 2 here. Okay. All right, from there I'll go to the last one, which is part D. So theta equals pi. All right, so here, like, you know, it's actually sometimes easier if you just, like, technically you could take the tangent on both sides because you get tan theta, which is an equation that we know of. But sometimes in this case, especially, it's like easier if you just imagine, just like draw out the points. So like, you know, just like we had with part A, where we had like r equals 3, and we like just draw the points, right? Draw the points that describe r equals 3. We can do the same thing here, right? So theta equals pi. So think about all the points with a theta, an angle of pi, right? So let's say you had 1 comma pi, right? So that would be located here, right, on the negative axis. Let's say we had 1 comma, well, it has to be pi, right? So like it could be like 2 comma pi, which would be here, right? Say, let's say we had negative 1 pi, that would be here. Negative 2 pi, right? Sorry, we rotate this way. We would this way. 1.5 pi, we would be here, then rotate 180, we end up here. Negative 1.5 pi, we end up right here. Right, so you guys get the point. So all these points are going to be on this line, which is the polar axis, right? Or in rectangular form, that's the x-axis. Okay. So this, again, this describes all points with angle equal to pi, which is the x-axis, or y equals 0. Right. So y equals 0 would be the rectangular form. Okay. All right. But yeah, so that's just a sample of the type of questions you'll see on this topic. From there, it's just the classwork. So we do have 10 minutes left. So I want you to go to the classwork on Google Classroom and just work on that. I'll also show it here if no one else needs the solutions here. Okay. But yeah, is anyone still copying this? Any of these? No? Okay, I'm gonna move on then. But yeah, for the rest of the class, just work on the worksheet. Just four problems, I believe. Was it? Yeah, 4 problems. And okay, this is Java here. Let me move this up. Yeah, 4 problems. Convert the following equations to the opposite format as we did in the last example, and identify the graph when possible. Okay. Yeah, so the first equation, x equals 1. Second equation is polar. Third equation is also polar. And then 4 is a parabola. All right, but yeah, see what you can do in the next 5 minutes, and then we'll reconvene. Let's make it 4 minutes so that we have 5 minutes to review. So let me pause you here. Just want to make sure we have enough time to go over the solutions. So I'm going to scroll up. All right, first one, we had x equals 1. So x we're going to replace with, this is in rectangular form, so we're going to convert to polar. We're going to, replace that with r cosine theta. We get r cosine theta is 1. Divide both sides by cosine theta, and we're going to get secant theta, right? So as you see, the format for polar equations is r equals something theta, right? Just like y equals something x, okay? Yeah, that'll be the form of this answer here, r equals secant theta. All right, next we have r equals 5 secant theta. So secant theta, we're going to rewrite that as 1 over cosine theta. And then from there, I'm going to cross multiply. You get r cosine theta is 5. R cosine theta, we know that's equal to x, right? So x equals 5, which is a vertical line, right? So yeah, in rectangular form, x equals 5. So the x coordinate is equal to 5, so that'll be like right here. Yeah, imagine it's not slanted, but yeah, the vertical line, okay? But yeah, you should even like infer that from this first answer, right? R equals secant theta. And if you look at this, right, 5 secant theta, right? R equals secant theta is x equals 1. 5 secant theta, that's x equals 5. Or sorry, r equals 5 secant theta is x equals 5. Okay. All right. From there, we have question 3. Actually, would anyone like to explain this? It's a circle. Yes.
So basically, we know that, well, first what we do is multiply both sides with r so that we can use the identities that we learned, and then replace r squared with x squared plus y squared, and replace r sine theta with y, and then that gives us x squared plus y squared equals to y. Then if you bring all the variables to one side, we get x squared plus y squared minus 2y, then we complete the square, and we get y squared minus 2y plus 1 equals 1. And then if we factor out y squared minus 2y plus 1, we get y minus 1 to the power of 2. So our final equation is x squared plus y minus 1 to the power of 2 equals 1, and that is a circle with radius 1, center at 0.
All right, very nice. Yeah. Yeah, I just want to emphasize this point. So here we completed the square, right? Complete. Well, I don't know if I'll write it out, but yeah, CTS complete the square. That's where we got the plus 1 on both sides. Otherwise, it would be like x squared plus y squared minus 2y equals 0, right? But we add 1 on both sides so that we can factor this to that. Right? Okay. Yeah, that'll be your equation for question 3. It's a circle. X squared plus y minus 1 squared equals 1. All right, lastly, we have y equals x squared, which we know is a parabola, but let's see how to write it in polar form. Okay, so we replace y with r sine theta. We're going to replace x with r cosine theta. We get r sine theta equals r squared cosine squared theta. And then here I'm going to divide r on both sides. So you get sine theta equals r cosine squared theta. And then I divide cosine squared theta on both sides. So you get r equals sine theta over cosine squared theta. And I'm going to split that up into sine theta over cosine theta times 1 over cosine theta. All right, so sine theta over cosine theta, we know that to be tangent. And 1 over cosine, that's secant. Okay, so this is equal to tan theta, secant theta. All right, so as you can see, right, this is a lot better to write in rectangular form. But, as we saw in the first lesson, we saw some graphs that are more easily graphed using polar coordinates, like r and theta. Some, like the parabola in this case, are more easily graphed using rectangular coordinates, right? Y equals x squared, right? This is a lot simpler than this, in my opinion. I guess this is like 2 terms, but yeah, on the right. But yeah, anyways, that's your final answer for question 4. All right, for closing announcement, there is SGI today as always at 2:47, and Yeah, last I guess last reminder. Leave a comment under quiz 4 if you want me to regrade anything manually. But yeah, other than that, hope you have a great weekend. I'll see you all on Monday. Take care.
Have a good weekend.
All right, thank you, you too.
Have a good weekend.
Thank you.
Thanks, you too.
Have a good
All right,
weekend.
bye.